Sorry, Dean and Gavin, welcome, welcome. We were talking about how we are just about to grade our homework, so they're checking out the answer key right here. Just for a hot second, but the beginning of homework actually had to do with anti-deriving, and there was some U sub involved, and we haven't technically reviewed it at all. So it's like, why haven't we reviewed it? Did we just skip it? Did our book skip it? What's going on? Well, check it, guys. What's section 7.2 going to be? Okay, so we're reviewing U sub, just the book kind of brought it up a little bit earlier, okay? To see if you guys could do it. Nice thing is you guys had seen it before. Anybody else for whom this is their textbook, it would have been like, what? You would have had to think a bit deeper about it. But there were also slope fields and Euler's methods for us to grade. So we're going to get back to notes in just 1 second. I thought there was one more announcement. Oh, in our notes, I do have some, I would say some good matching problems I kind of skipped over as far as with slope fields because we were trying to get to Euler's method because as you guys can tell, Euler's method took some time for us to figure out and some time for us to practice. We'll get back to these at some point. I'll have you guys probably just randomly as a warm-up or something play with the 2 multiple choice in the back of your notes. One is matching with y, one is matching with dy dx, but let's see how you did on homework without those practice problems. And see if you guys, ooh, that was a fun one, got stuck anywhere. So, here we go. Section 7.1, did you guys realize this was just an e to the u times u prime, which comes from an e to the u? It matched perfectly. Don't worry, we're going to review u sub. But e to the u times u prime, it matched perfectly. I see some of you squinting. There you go. That was just an e to the u times u prime, which came from e to the u. Plus c. This one, it's a 4u cubed times u prime, which came from a u to the 4th plus c. But we don't write it like that. Yes, we have the much nicer notation, sine to the 4th of u. Number 18, was that how it was written? 1 over t minus 1 over t squared plus 6? Oh, okay. I felt like they might have like split it up with the Hart method or something. Okay, so you said to use ln, you had to use a power rule, and you had to use a power rule. Plus c. But then you also were given an initial condition that you had to plug in, solve for c, and then state it in your final answer. The awkward part of this one is that it was an x of t, so x equals in terms of t, not a y equals, but an x equals. Okay, now some matching. Letter C went with number 26. Letter D went with number 28. You guys had some odds in there, I think you needed to grade as well. Number 34, you were just doing a few baby tangents. Some of you 2 days ago seemed to be struggling a little bit. Did it go better last night when you were graphing? Okay. Number 36, you were matching with E. Number 38 matched with D as in delta. E as in echo, D as in delta. Oh, you were also supposed to, were you supposed to graph the particular solution? Okay. Swoop, swoop. Number 40 matched with F, as in Frank. Of course, they give like description and whatnot as to why. Number 42 was also F. Is this a new section? Must be, right? Okay. Sorry, number 42 is F. Number 44 is E. F as in Frank, E as in echo. That one was a weird swoop. There it is. Because if you followed it, it literally never got into this portion. It was just stuck up here. Number 46 is A. 56, your final Euler's method approximation was negative. I thought it was Euler's. Is it not? Oh, it is. Wow, they show it weird. Is negative 0.271. They're doing this whole like, hey, here's the slope, here's the delta x, here's the, I don't even know. I do not like their way at all. But the final approximation would be negative 0.271. And for us guys, careful, there should have been an approximate with f of 1, f of 2, no, f of 1.8, 1.7. Oh, there it is. I see it. I see it. I see it. You're using 1.8 to get one. Ugh, I do not like that table. If you like it, go for it. Learn it, but ugh, I don't like it. negative 0.271 is approximately f of 1.7. Number 60, A matches with graph B. And B was talking about why A and C failed. Had to do with the signs of the slopes. If x is negative, the slope was supposed to be positive, but the other ones, I guess, had like a 0 or a negative, so that didn't make sense. 72 was E, 74 was A. 78 was a separable differential equation where you had dy dx, move it to the other side, a quick little power rule with plus C. Plug in your clue, get C. And then you had a few of those, I think. I guess just those. Okay, as you guys finish grading, you can see it up there. Is there anything in particular we need to talk about for section 7.1, slope field and Eulers? For brutal homework, you guys seem to ace it. Are we okay? Patricia? 53. Anything else besides 53, guys? 56. Okay, so two different Eulers, ones with similar given information, but a little bit different. 73, is that a matching one? Yeah. Okay, 53, 56, 73. Anything else going once? Anything else going twice? Sold. Just because Euler's method, guys, is new, let me just do it quick. Is that okay? Let me do a dual page so you can get both. And then the matching problem we'll look at together. I think I don't need to get anyone up to the boards today. If you were willing, I appreciate it. Just, yeah, that's all right. So number 53, and let me get it up here on the screen. Okay, I see 53 and 56. Ah, so close and yet so far. Your book is too wide. How about now? There we go. Okay, 53 gives us the function, or the differential equation, y minus x. Y equals 2 and x equals 1, going by point ones. And then getting to 1.3. Is it y minus x? And we know y of 1 equals 2. Is that what we're doing? We're trying to approximate. I'm going to do f of 1.3 using. You guys see how they give you a differential equation, they give you a point, they give you either steps or some sort of idea. They could have said using 3 steps, and you would have known that as well. Double check my initial point, that was right, right? Okay. So we start off with y of 1 is equal to 2, then y of 1.1 . You guys agree with my approximate? So as soon as I get off that point on the curve, now I'm in trouble. Not in trouble, but I'm off. Okay, how does Euler's method work? It's really just, if it helps, it's really just a linearization technically, right? P.S. I took a quick picture of our Eulers, our 10 steps, and I sent it to all the kids who had been in my BC classes, and I was like, remember what topic, question mark? I had all of them say Eulers except for one kid who was like, oh, it's linearization. Kyle Bobby down in UC San Diego. He was like, AKA Euler's method. And I was like, oh, good job. Very impressed. Anyway, see, it's memorable. Linearization, I just need a y, right? A y1 plus dy dx, which is going to be like the big F of whatever I have, times x minus x of naught. Remember how this guy is just my h, this guy is just my differential equation, right? And that guy is just my y. So, can't I just steal my y? Yep. Then what? F of, remember we had to look back. 2 times my h is 0.1, true? And so plugging back in, okay, 2 minus 1 is going to be, right, y minus x. So 2 minus 1 is 1, 1 times 0.1 is 0.1, this is going to end up being 2.1. That keep going, true? Right. Now it's 2.1 plus, what's going in my differential equation this time? 1.1 and 2.1 times 0.1 equals, wait, 2.1 minus 1.1 is still just 1. Oh, so 2.2? Maybe it's a pattern. So 2.2 plus, what's going in now? Oh my goodness, it's going to be the same thing every time. It's going to be just adding 0.1. So if you want to make sure, oh, we're done. Just kidding. We find the pattern as we finish. Does that match up, guys? So my f of 1 point. You ever do that? Your brain knows and then it writes something different. So 56. Janelle, what's my differential equation in that one?
1 plus y.
So like this one I was plugging in x and y, now I'm just plugging in y. What was my original point?
2, 0.
For y of 2 equals 0. And then, where were they trying to have me go to?
1 second.
Using
Negative 0.1.
Oh, so I must be going down from something. Oh yeah, because I'm at 2. So Euler's method, you can go up and down? Yeah. You can take negative steps too. So I'm going to start at f of, or y of, either way. Doesn't matter. Y of 2 equals 0. So I'm going to go down 0.1. Down 0.1. Then down 0.1. And the nice thing is, the only thing that's going to change, I still use my old y. I still plug in my old point to my differential equation. Sorry. Which is 2, 0. But do you actually plug in the x at all? No. And then times, all that's different is I have a negative 0.1 that I'm multiplying by. Because I'm taking that backward step in a sense. And so plugging in, it'd be 1 plus 0, because the x doesn't matter. Which would be 1, negative 0.1, that'd just be 0 minus 0.1 is... Right? How about 1.8? So I start at my negative 0.1. F of, wait, do I even really need the x? Isn't it just in terms of y? Oh, sweet. So what's the old y? Negative 0.1, 0.1 times my negative 0.1. So what's 1 plus negative 0.1? Isn't that 0.9? And what's 0.9 times 0.1? 0.09 with a negative, negative 0.09. So it would be negative 0.1 minus 0.09. Got it. So I use my negative 0.19 plus f of that negative 0.19 times my negative 0.1 equals. So then 1 minus 0.19 would be 0.81, right? Yeah. And 0.81 times 0.1 is 0.081, negative 0.081. So negative 0.087 carry the 2, 271? I don't know. That's in the answer key somewhere. We can double check. How is number 56? They showed it weird. I don't know. There you go. So my final F value approximation. So that H step, if you're going backwards, you just have to make sure that you have the negatives. Okay, and then you said number 73, right? All right, guys, this guy's a matching one. Let's go have some fun. So the matching one says, if, hey, differential equation, dy dx equals 2xy. Wait, what order differential equation is this? First, because what's the only derivative you see? A first derivative? Anyway. If dy dx is equal to 2xy and y equals 1, when x equals 0, then y equals. Oh, that's fun. Could you technically go through and take the derivative of every single one and see if any of the derivatives are 2xy? But some of you might be looking at this and being like, huh? Need an ln for that one. This one's pretty easy. E to the u times u prime. Definitely not b, like if I was just doing a really quick. Sound like one of those you know what I'm talking about, the snappy things?
No, it was not. It was the
Or was it?
Ow.
Water bottle, just like pop.
What a night.
Okay, anyway, so
Oh, it's gone? You have a scarf.
this would be second d first plus first d second. Wouldn't that have a y squared 2x plus first x squared 2y? That's not gonna work. That has squares in it. So then these ones, quadruple second d first plus first d second. That's a little bit nasty. You could also, if you wanted to, you could also actually separate the differential equation, right?
Miss D,
Huh.
I think the answer is Eta.
Yeah.
It is. Yeah, hold on.
Oh.
Because I just cancel out those two, and then we don't have to find that one's derivative, right?
Yeah.
Because what I just said was second d first, so that'd be 2xy, but plus first d second. Wait a minute. No, that doesn't work. And then that would be the same thing with a plus 1. That doesn't work. See how I just like, uh-oh. So is it that one that I don't know? So then what did I start doing over here? Sorry, I should have crossed out and been like, uh-oh. Don't I need this one to be over y? So then I would have an ln of y equals x squared plus c. True? How do I get to my y? E to the then I have an absolute value of y is equal to, remember with an addition and exponents, isn't that multiplication?
Whoa.
Wait a minute, but that doesn't make sense. I know his derivative. His derivative is easy. His derivative is e to the u times u prime. Wait a minute. E to the u times u prime. Isn't this the same thing as this? Oh, it would have been 2xy.
Wow.
Because y equals e to the x squared, so it was y times an additional 2x. It was what it originally was times a 2x. It just looked weird when they wrote it with x and y instead of writing it with who y was with his 2x.
This is just too much for today.
Okay. You need to actually write y equals e to the x squared. Can't I substitute in y for e to the x squared? Yeah. So it was written weird. You're like, no, I know that one. It's e to the x squared times 2x. Haha, not, oh, yes. Now, technically, if there were more than one of those, wouldn't you have to come back in and say, uh-oh, so I have my 0.01, so when I plug in x to the 0, I need this guy to be 1? Oh, okay, c equals, dun, 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 dun. Sometimes the simplest ones are the right answer, but they might look like the wrong answer.
It's kind of like, not autonomous, but like, about the AP exam and like Horowitz method.
Okay.
So like, will it show up on the FYQ? Or is it just like a multi-year?
I've seen it as like a part A. Think tangent line approximations show up as like a part A, right?
Is there any way you can like stick it to the man for like Horowitz? Or like, because you have to keep on using.
Because you have to build on it. You can't build on it without. Now, could you write it in a long, drawn out? Yes, but then it's just going to get worse. Do I still have those examples? Yeah. So like, I'm mental math jumping straight to the right solution. Okay, so let's think about it. Because you have to have a numeric, to stick it to the man, you have to have a numerical expression of the correct answer, right? So you can't have like a dy dx if you need to have it all in terms of x. You can't have a y if you need it all in terms of x. You can't have like a derivative or an integral that needs solving that hasn't been done yet. It has to be like a final solution that just hasn't been algebraically simplified. So for, I mean, this one's obvious. How could I have done this sticking it to the man, which is very practical because you don't want to make mistakes. That one's easy. Okay, I could have done 1 plus 0 times negative 0.1. I could have stopped, but check what you would have to do next. Because that is a numerical expression, right? Then I would have to do 0 plus 0 times negative 0.1. That's y plus 1 minus times. See what I mean?
It's not the like the worst thing.
It's not the worst thing in the world, but you could simplify. I mean, it depends on the problem, what it is. The 0 plus and then 1 plus 0. Like, you could theoretically leave it partially simplified, right? And that wouldn't necessarily be awful. To be honest, the Euler's method that I've seen them have you use doesn't even have decimals, which means it's not a great approximation, but they're just trying to see that you know the process. It's not so much how hard can we make the mental math. Does that make sense? But we can keep an eye open for when it does show up. Yeah, keep an eye open for when it does show up. With that, guys, I think we got to the rest of our homework questions. Let's go have fun with integration. The rest of chapter 7. I don't know if I can say that. We're trying to get through chapter 8 in first semester. But then second semester is chapters 9 and 10 and a little bit of 11. What does that mean? Chapter 9A and chapter 9B and chapter 10A and chapter 10B. We're slowing way down. Why? Because it's all woo! Well, it's mostly now. We get back to parametric and polar. But some people are trying to put or wanting to put polar curves on their sweatshirt. That would be fun. Sweatshirt. Lamos. You should get one. Okay.
Yeah, we should.
Yeah, we should. Chapter 7. You guys ready? 7.1. Schofield and Euler's method. 7.2. Anti-differentiation by substitution. 7.3. Anti-differentiation by parts. Integration by parts. Tick, tack, toe. Stand and deliver. Section 7.4. Exponential growth and decay. And then section 7.5. Logistic growth. Hey, does chapter 7 have some new stuff? Yes. Euler's method, topic number 1. Integration by parts, 7.3. Topic number 2. Logistic growth, 7.5. Topic number 3. That would be fun. So, last year, was I picky? Was I particular about you guys? Not particular solutions. Never mind. Was I particular about you guys showing your U sub for integrals?
Yes.
But in BC, I hope you can do it mental math. All the time? No. But more. Some of you aced the mental math last night with e to the sine of theta times cosine of theta d theta, or I should say cosine of theta times e to the sine of theta d theta. Some of you were like, oh yeah, e to the u, no big deal. And others of you were like, Okay, so remember, with derivatives, we're not quite all there to mental math yet with u sub. But remember, indicate the derivative of chain rule. Isn't derivative of the outside keep the inside times derivative of the inside? So if you're looking at something that's inside an integral, and if you can clearly see a derivative of an outside with a perfect matching derivative of an inside, can't you just go straight back to what the composition was? Now careful, I just said matching perfectly, right? And similarly, if you have another one, well maybe you have a u inside a v inside a u, or an h inside of a g. Why can't I see the parentheses? Chain rule just keeps on going with however many insides you have. Just keep on unveiling the matryoshkas. Is there another one? Oh, let's keep going. Is there another one? Oh, let's keep going. Is there another one? So if you see an integral with a clear derivative of an outside, keep an inside, times derivative of an inside, you're like, sweet, it's a chain rule. I can go straight back mental math style to who he would have been. Ah. Or if you see a clear derivative of an outside with, then the next derivative of the inside with, and then the next derivative of the inside. Hey! Now, do I really want you solving all integrals by hand? Sorry. Yes, I do. All integrals using mental math? No, probably not. Do I want some of you doing any of them mental math? No, probably not. However, do I think quite a few of you can master integration a lot more than you did last year? The answer is yes. So, pattern recognition. Can you see the use a bit better? Hey guys, how am I teaching Algebra 1 to do factoring right now?
Boxes.
Technically the X method, but I'm having them take the stuff they see in the X and put it in the box and go that way. And you might be like, what the? Just in case you tutor an Algebra 1 kid. Let's say I were to give them something like 4x squared minus 2x, no, sorry, 3x squared. And then plus minus 8. Did I do it that time? Yeah, I did it that time. I would have them put factors of 3 times negative 8 are negative 24 and then negative 2. Hopefully they would figure out negative 6 and 4. But instead of saying, great, take this guy, negative 6x and positive 4x and group and don't make a mistake and don't forget to group. Instead I'm like, forget it. Put in the 3x squared. Put in the negative 8 and say, I know that the other guy came from a negative 6x and a 4x. And then just say, what's in common? Well, there's a 3. Nope. There's an x in common. Okay, cool. There's a 3x in common. Okay, cool. There's a 4 in common. Okay, cool. There's a negative 2 in common. Guess how often this method works? All the time. It's pretty spiffy. It's pretty cool. And it does the job of grouping without them making sign mistakes. I'm hoping it helps them. Now when they get into pre-calculus, do I really want them all still making boxes for every single one? For every single one. I want them to master it. I want you guys to be able to factor without having to show all of this crazy work, right? Integration, same idea. Could you show just as much work as last year? I suppose, but should you theoretically be getting better at it? Huh. So, why or how, oh that's me. I want to have fun, but I don't want to totally kill you at the same time. So, how about I give you guys 120 seconds to write it down, to think about them, to solve them, and then I'll start giving answers. Maybe you have them done, maybe you just have them ponder. 2 minutes. One more minute. Man, time goes slow sometimes. Maybe you're pondering, maybe you're solving them, maybe you're showing work, maybe you're going straight to the answer. Shh, don't tell me any answers. You don't want me to cheat. For those of you that are stuck, are these the basic mental math, simple follow the rule ones of last year? Are these simple like plug into the rule ones? No. No. These are not ones that I would have done mental math last year. But this year, maybe some of you guys. Could do them without any work. How?
It's just doing like you sub in your head.
Kind of. But actually not really. Not the process of USub. Because remember the process of USub last year? Some of you are like, no, that's the problem. Okay, pause. Process of USub. How would we have solved number 1 last year? We would have said, we think, well, actually most of you probably would have just distributed and done some weird like power rule and had some polynomial. But anyway, a 4th degree polynomial, by the way. But this year, maybe you could have seen that x squared plus 4 is the u. Then wouldn't we have gone to du is equal to 2x dx? And then wouldn't I have had you take that off to the side and say dx is equal to du over 2x? And then wouldn't we have gone to substitute and say, oh hey, look what happened. Don't we have the 2x? So can't I say that's really just a u du? And how do I integrate u du? What did I do? I saw this 2x and I said, hey, I'm pretty sure he's a u prime. Was he a u prime? Yeah. So what can I do with u primes? U primes are just, check it, u primes are just du's. So I was able to ignore the u prime and just focus on the u and say, sweet, u to the 1 is 1/2 u squared. Done. What was my u in this one? What's my u prime? Who's this guy? Just u prime. Technically, du is 3x squared dx, but still, u prime fits perfectly. So I can think of this as, oh sweet, it's a 1 over u squared. Ugh, a u to the negative 2. Add 1. U to the negative 1 divided by a negative 1. Dun, 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 dun. Who's your u on this one? Tangent. Why? Well, if u is tangent, do you see how I zoomed in on the secant squared and said, oh, that's the derivative of u prime. If I can see a u prime, I can basically ignore the u prime and say, oh, it's a u to the 4th, 1/5 u to the 5th. Okay, do you have to do these all mental math? No. I'm just trying to show you, if you think ahead just a little bit, you might be able to save some work. Does that kind of make sense? So can we take that homework problem from last night? What was the one that some of you got stuck on? The integral of, was it a t or a theta? T. Some of you looked at it and were like, yeah, if you thought cost, well, we just have some issues. But anyway, it's okay. Cosine of theta, cosine of t. But yeah, I looked at it and said e to the u times u prime. What? Yeah, because e to the u, this has to be u. So, oh, well, that's nice. He's just a u prime. How do you integrate e to the u? Well, e to the u. Let's see. Do you have to think like me? No. But can some of you? I'm pretty sure. E always has a u. ln always has a u. Inverse trig? Oh, you don't know how to do that yet. Always has a u. Anyway. Don't worry, this section is not do it all by mental math. Be fun if it was. Let's get a few more examples. You guys saw that the title of this was anti-differentiation, right? AKA just lots of intervals. Substitution, whether mental math, whether cheating and kind of shortcutting, or whether actually showing the work. Some of you right now need to be doing u equals 3x plus 1. No shame. U equals 3x plus 1. Du is equal to 3 dx. Some of you just go old-fashioned. Just a few of you might be like, huh, I want a 3, and I don't have it. Some of you might be like, huh, I want a 3, but I don't have it. It's a little bit harder. I will show it the long way, then I'll show it the shortcut way. You're doing it the U sub way. There you go. You're doing it the mental math way. Huh. I really wish I had a 3. Well, I could do that if I do it this. I could just go ahead and pull that out and say, yay, U prime. So I have u to the negative 1/2, so I can go ahead and say 5/3 times u to the 1/2 times. Got it. You can bring in what you don't have. Huh, u prime, I need a 3. Okay, cool. Put a 3 on the inside and 1/3 on the outside. Pause. Do you have to go about it this way? No. And when you speed up, what is a danger? Always. Even in a car. Making mistakes, right? What did I do? My shortcut, I found my u. I thought u prime is 3. I'm like, oh, I don't have a 3. Well, I can bring the 5 out, but I want a 3. Well, 3 and 1/3. I'm not messing anything up. You know how we would multiply by 1 creatively? I was like, yay, a 3, but I had to offset by a 1/3. You see it? And then my 3 was my u prime, and I was able to think of just u to the negative 1/2. 5/3 was the extra constant. U to the negative 1/2 plus 1 is u to the 1/2 divided by 1/2 is times 2. It's like this math is happening, just creatively. Okay. So what about the next guy? Ah, he has bounds.
I thought
That's a 4.
I have to go 15 miles an hour.
Are we now talking about cars and how we shouldn't be going fast enough?
Speed bumps are done.
Yeah, they are good.
I agree.
Especially in the hospitals, those are like the worst.
I don't go through that.
There's only two
Pause. Could you do U7? Yes. Can anyone walk me through a shortcut way of thinking about it?
So we know 2x squared is u.
Close. What's u prime? Not 2x squared.
3x.
So wait. The 2 doesn't help. I need a 3, but if I ever put in something random, what do I have to do? Offset. Right?
Wait, what?
What's my u prime? 3x. Aw, not a 2. Pull the 2 out. I want a 3. 3 over 3. Oh. And then I have my u prime. I'm showing you my mental process. So then it's u to the 4th. Oh, easy. It's 1/5. U to the 5th, but I have this little extra 2/3 dude. From negative 1 to 4. Why am I able to use the negative 1 and 4? Because I never went to use. Oh, interesting. But what if I had gone to use? Okay. U is equal to x cubed plus 1. Du is equal to 3x squared dx. Dx is equal to du over 3x squared. We could have gotten this to be, let's see, the x squareds reduce. The 2 over 3 is going to be there. I'm going to have a u to the 4th du. What would my new bounds be?
I know the top is 67.
Because you're doing u of the top and u of the bottom for the negative, sorry, for the new top and the new bottom, right? So 64 plus 1 is 65, and negative 1 plus 1 is? So you could just do 2/3 times 1/5 u to the 5th. Do they both work? Yeah. What's going to happen when you plug in over here? 2/15 times 65 to the 5th minus negative 1 plus 1 is 0 to the 5th, right? What's going to happen when you plug in there? Same thing.
Yes, Steve.
Yeah.
Wasn't there like a way you taught us last year? Like if we do go into u, we can use like the x bound to like write it.
Huh.
And you know.
Yeah. Just trying to figure out where to put it. That way you could go ahead as the indefinite integral, but 4 definite bounds, but the x's don't match the u's. That way you aren't technically doing anything illegal. So you could do your 1/5 u to the 5th. Then you could go ahead and plug in the x cubed plus 1, 1/5, x cubed plus 1 to the 5th. And then you'd be able to use your original bounds, and you never had to go to u's. But you guys also know the AP and that they don't always give you the equations, and so you have to do things like make u bounds without being able to stay in terms of x. Does that make sense? With their like, oh, let capital F be this dude and little f be that dude, and you're like, I don't know who they are, but okay. So at the end of the day, what is the final answer? So, oh, that's what we just did. So if you're given, it's really hard to generalize this one. If you're given an original integral with integrand in terms of, oh, here we go. I got it. I can be AP-ish. Ready? You have a to b. They're x bounds because I have a dx, and I have an f prime. How could they do that? I think they would have to have a g prime somehow in there. Then this could be f of u from g of a to g of b. Does that make sense? Because if you have a chain rule, you can go back to the antiderivative, and then your g is your u. So to find your u bounds, you could do g of a and g of b. I guess this would technically be yeah, I guess that's right. So your u bounds, you would plug in the bottom bound. Remember, it has to stay on the bottom, even if it's bigger. Plug in your top bound. Remember, it has to be on the top, even if it's smaller. And then your antiderivative would be the antiderivative of the outside because your u prime is perfect. Ugh. Kind of gross, though. But that's how you would make u bounds in some sort of generalized fashion. Guys, I know we're going down to like 2 minutes left. In some ways, I'm having some fun, and in some ways, I'm kind of like overwhelming some of your brains. The long story short is, do we have basic integration rules? Yes. What is going to be new? Well, it kind of started last section, but now it's going to be integration that's a bit more complicated than the basic antiderivative, and that it's u that are, well, the arguments are going to be used. Chain rule is going to be necessary to consider at some point or in some way, shape, or form. We do have the basic rules that we've already seen before, like u to the negative 1 or 1 over u, that needs to go to ln. We have the basic power rule. We have our trig rules backwards. However, what do you see here at the bottom that looks new? A guy that some of us messed up on last night, right? A guy that some of us never did really get down. And 2 brand new ones that we're not exactly sure how they work yet. Don't worry. In section 7.3, I'll show you why this is true. For right now, it's a thing. Sorry. It is what it is. Yeah. He did you. So, just cause, why not? We need more endeavors anyway. Endeavor number 4. 2 in 1 week? 2 in 2 days? We're having fun now. You guys got it? Yeah. Anyway, can you finish your entire homework tonight? Maybe? Do you need to? No. So why don't you split it up? Half tonight, half tomorrow night? Sound good? Yeah. And if it doesn't sound good, have fun tomorrow night. Hey, tomorrow night's a 3-day weekend. I want to do homework all weekend. I never been doing homework all weekend. But if you don't, why not start tonight? Yes, the homework is not due on Monday, it's due on 3-day weekend.